Hello, I am Dr. David Kordowitz here at Grand Canyon University. Today we're going to take a look at how to use some of the tools in Solidworks for modeling static objects and assessing how they react to different forces applied. So what we have here on the screen is a bridge which I've built based on the cable stay bridge you can find at 59th Avenue and the 101 in Phoenix, Arizona. And this bridge is relatively interesting and has an interesting form. So today we're going to go ahead and take my model here and test it under some real world loads. So let's begin this project by first of all making sure that you go to SOLIDWORKS add-ins and make sure that the button for the simulation is depressed. If it is not depressed, please do so now, and doing this will make the simulation tab appear on your ribbon. So once that happens, go ahead and click on the simulation tab and we're going to pick New Study. Just go ahead and click on New Study, and you're going to get a list of all different types of studies. But for the purposes of today, we're going to pick a static study, given that motion in a bridge is probably not something that we want to see. So we're going to do a static study and click OK. Once we do that, that's going to build up our study parts and allow us to actually apply loads, forces, and fixtures to our bridge such that we can test it under the conditions we're looking for. The first thing we're going to do is set up fixed geometries. So to do this, we're going to go ahead to where it says Fixtures Advisor. Don't click on the Fixtures Advisor, but rather click on the little triangle at the bottom, and then we can pick Fixed Geometry. We have a number of different fixtures that we can use. However, for a bridge, again, things don't really move, so we want to use a fixed geometry where things aren't moving. On this bridge, we're going to have 3 points at which we have fixed geometries. The first being the end of each end of the bridge. We don't expect the bridge to move relative to the land on the side, and we're going to generally assume that these endpoints are anchored to something in the ground. On this particular bridge, we have a single tower which is in the center, and we're going to assume that that tower itself is fixed to the ground, so we're going to put fixtures there. If you notice, there should be green arrows at each of these major points, representing that that geometry is fixed and will not move within space. So at this point, we're going to click OK, which is going to go ahead and set our fixtures. The next thing we need to do is load our bridge. To do this, we're going to go ahead to the External Loads Advisor, but again, we're going to click the triangle at the bottom, and we're going to pick a force. In this case, we would expect there to be a force based on car traffic, foot traffic, whatever is applying to the bridge, and we expect that force to only be applied on the road bed. So what we're going to do is we're going to turn this, and we're going to select our road bed. And if you notice, we get a bunch of purple arrows pointing down, vectors pointing down at our road bed. If we look on the side in our menu here, in our flyout menu, we have that we want to put a force onto it, and we've chosen the face of the road bed. The next one is normal versus selected direction. Normal means that we're going vertically down, where selected direction means that we have an angle. In this case, we want normal because most vehicles or foot traffic or whatever is going to be pushing straight down on the bridge and not an angle. If this bridge had an incline, there's a possibility that that angle would be different. The next thing after that is the type of units. Right now it's set to SI units. We have the option of pounds, and we have the option of using G-force. For today's demonstration, let's use pounds. Given that we're going to do this in tonnage, pounds makes the most sense. 1 ton is 2,000 pounds, and let's assume that we're going to apply 10 tons to the bridge. So that's going to be 10 times 2,000 or 20,000 pounds. If you notice, the arrows got a little larger. This is because of the increase in the force. Continuing down, we have the ability to reverse the direction. However, that would be a pull force pulling up on the road bed, which is very unrealistic compared to how we would expect things to work. Finally, we have the choice of per item versus total. In this case, because we only have one single surface chosen, their total and per item would be exactly the same. If we had more than one surface, these would be different. So at this point, let's go ahead and click OK and accept our forces. And if you notice, we have our forces pushing down on the bridge now and our green fixtures applying. The next thing we can do, we don't have to, is we can go into our mesh. And so if we right click on the mesh, you can go simply to your Create Mesh button, and if you click there, it should bring up a menu on the left which gives you the ability to set certain things. Right now it is set to dead center between coarse and fine. For this type of bridge, that is okay. However, on some of your bridges, you're most likely going to have to make it finer, otherwise it will error out when you try to run it. In addition, you can set different mesh parameters, such as the shapes of the mesh. If you have problems getting yours to mesh, go ahead and pick the blended curvature-based mesh. This will often solve many of those problems. So we're going to say OK and accept the default values. And as soon as you're done, it's going to go ahead and run the solid mesh generator, which basically converts your bridge into a series of triangles. These triangles are the different elements that we're going to run our finite element analysis on. At this time, everything should be good and set, so we're going to go ahead and hit run this study. Once we hit run the study, it's going to run for about a minute or so, depending on how complex your bridge is. The more complex your bridge is, it's going to take longer. And then once it's completed, it will show us some results. Now, one thing I want you to notice is, first of all, your bridge seems like it's completely folded up. And I don't care how strong your bridge is, it's going to look like it's completely folded up. So if we look at it here, we have stresses shown, because if we look at stress 1 von Mises, and our stresses range from about 0.4 to somewhere around 73,000 or 730,000. Now, in reality, the displacement we're seeing and the appearance of this bridge really isn't true. So let's go over to displacement. So all I'm going to do is double click on the one that says displacement, and now things are going to change. If we look at this, our displacements are somewhere between 1 times 10 to the negative 30 and about 0.2 millimeters. That really isn't all that bad. So what we can do is, if we right click on displacement and we go to our edit definition, it's going to take a second to open, but if we look at it, our scale here is somewhere around 26,287 to 1. That isn't very realistic, but if we hit true scale and then click OK, this is going to give us a very realistic view of what our bridge has done. In the locations that are red, such as the left and the right here, this is where we see the maximum displacement of about 0.2-ish millimeters. That really isn't all that bad when you think about it. So basically, we're now looking at this, and we can do different things, such as taking samples and getting specific location information. So you can click on points, and it will tell you things about those points. You can generate a report if you want to, and different things like that. We have our plot tools. You have your probe. Your probe will allow you to get actually very exact. You can click a point. It's going to tell you exactly what the displacement is and exactly what the position is. This is a really useful tool if you're trying to analyze something that you've built and are trying to figure out whether or not it will work under physical forces. So this concludes our introduction to the finite element analysis methods within Solidworks. I want to wish you luck on your bridge projects, and hopefully this video has helped you and will make this an easier project to complete. Thanks again, and have a wonderful day.